Distinguished guests, dear friends from all over the world, greetings to you all. My name is Ouyang Minggao, professor from Tsinghua University of China. Ladies and gentlemen, the title of my report is Opportunities and Challenges of Hydrogen Energy Development. I'll introduce my report from three aspects. Firstly, the strategic position of hydrogen energy in the context of carbon neutrality. As we all know, we have experienced two energy revolutions, and first one was the change from use of wood to the use of coal, and the second energy revolution was about the change from coal to oil and gas. And now we are at the stage of a third energy revolution, which is the change from oil and gas to renewable energy. In the middle of this, our most important energy carrier will change from petrol and diesel to electricity and hydrogen. So now we have new energy sources that will become the mainstay of the power system. In China, wind power and PV will grow significantly and will become the main installed capacity in 2030, while the cost of PV will also continue to fall, and in 2035 the cost of PV will be reduced to 0.1 renminbi per kilowatt hour. This is all about the increase in the proportion of renewable energy and a decrease of the proportion of carbon power and also the coal power. So with renewable energy as the mainstay, we need to establish a new energy system that is oriented towards carbon neutrality, which is about achieving a new energy revolution. Chinese President Xi Jinping has already proposed a low carbon development goal for 2030 and 2060 in China, and also a major strategy for energy to revolutionize. China's PV and wind power technologies and costs are now fully equipped for large-scale promotion. However, energy storage is the bottleneck and needs to be solved by batteries, hydrogen energy, and electric vehicles. And then in the middle of new energy revolution, we have 5 pillars. The first is transition to renewable energy, and second is the transition from centralized to distributed model, turning buildings into micro power plants. And most importantly, thirdly, it is about storage of intermittent energy with technologies such as hydrogen and batteries. And fourth is to develop the energy internet technology. And finally, there is the use of electric vehicles, making it becoming a terminal for energy use, storage, and energy return. So if we want to achieve a new energy revolution, we have to achieve the large-scale development of the new energy vehicles. And only by achieving a new energy revolution can we successfully achieve China's goal of carbon neutrality. So in this new energy revolution, hydrogen energy occupies an important strategic position. The strategic significance of hydrogen energy lies in the fact that its large-scale energy storage and diversified utilization needs in the transition to renewable energy. In other words, electricity is a mainstay, but at the same time, there is also a part of others, which is hydrogen is another energy carrier, which has diverse application needs. At the same time, the hydrogen energy industry has potential advantages in the low carbon transition of energy. First off, hydrogen energy is ideal for the transformation and upgrading of many traditional industries, including fossil, coal, nuclear power, steel, etc. The technology has a good continuity rather than complete disruption to the current infrastructure. At the same time, hydrogen energy has a long industrial chain, high production value, absorbs a large number of employed people, and has a wide application coverage. So we have a hydrogen energy society to support. First off, hydrogen energy transportation will be an important direction for the electrification and carbon neutrality for long-distance heavy-duty transport. hydrogen energy transportation is the pioneer field of hydrogen energy utilization, and its important mission is to drive the overall development of hydrogen energy. Then, on the other hand, hydrogen energy storage is the core technology of new energy power systems. So this is a graph of showing the scale and duration of energy storage in our power system, from which we could also see that hydrogen energy is one of the most important areas of energy storage, especially in the long cycle and large scale scenarios. So this is why hydrogen is the best way to store centralized renewable energy on a large scale and for a very long time. The reason is, firstly, the adequacy of use of energy. Large capacity and long duration storage models make fuller use of renewable electricity, and this can only be achieved through hydrogen. Secondly, economy of large-scale energy storage. For stational scale energy storage, hydrogen storage is more than an order of magnitude cheaper than battery storage. Thirdly, it is complementary to the discharge of batteries, and then it is a high-capacity, long-cycle, flexible energy source. Hydrogen can be used in the fuel cells, gas turbines, power generation, and so on. And finally, the flexibility of the way hydrogen energy is transported and stored. It can be transported by long pipes, trailer pipelines, hydrogen blending, long-distance power transmission, local hydrogen production, and so on. So we think this is the best way to go. Our hydrogen demonstration in Zhangjiakou, China shows that when the cost of renewable energy generation is below 0.15 renminbi, the economics of the whole chain of energy use will emerge. And then, from the point of viewing of achievement of a zero carbon economy, the demand of hydrogen energy in China is huge. It will then increase from the current 25 million ton to over 81 million ton. And this is the first part of the demand of hydrogen energy in areas such as chemical, raw materials, steel, cement, aviation, shipping, heavy road transport, and light road transport, etc., etc. So we do need a large number of hydrogen in those areas. And then in the second part, I would like to briefly introduce the progress of hydrogen fuel cell vehicles here in China. So then we have three kinds of vehicles and three kinds of power systems for new energy vehicles, that is hybrid, pure electric, and fuel cell. And among them, fuel cell is one of the three types of new energy vehicle. The power system of the fuel cell vehicle is fuel cell engine, which is similar to the internal combustion engine in terms of the peripheral of the system. However, in terms of the core energy conversion, it is similar to a battery that is using electric chemical conversion. And after nearly 20 years of development, we can see that the current state of the technology in 2020 compared with that in 2015, the performance indicators have been significantly improved. For example, the fuel cell life cycle has been increased from the original 3,000 hours to more than 12,000 hours. At the same time, these technologies have been tested in a series of demonstrations such as the Beijing Olympic Games in 2008 and Shanghai World Expo in 2010, as well as the United Nations City Fuel Cell Vehicle demonstrations. And now, according to the statistics in 2020, China has promoted 6,500 fuel cell vehicles, basically all of which are fuel cell commercial vehicles. So China is the country with the most number of fuel cell commercial vehicles running on the streets in the world. And then in terms of hydrogen energy infrastructure construction, by 2020, 74 hydrogen refilling stations have been built in China and 32 are under construction, making a total of over 100. And then the main distribution areas are all over China. I would like to introduce some typical commercial vehicle products of fuel cells in China. For example, 12-meter fuel cell bus with a range of 700 kilometers, and also a reduced hydrogen consumption of 5 kilogram per 100 kilometer, which could be competing with diesel vehicles, especially for operation in northern China cities. Heating in the winter time is entirely possible with fuel cells, and cost is more competitive compared to pure electric in winter. This is fuel cell engine, which is completely developed by China, and also it has a very good low temperature performance and can achieve a cold start at minus 30 degrees Celsius. This is the performance index of the electric pile, which is the power system of the whole fuel cell bus. Another typical product is the fuel cell refrigerated vehicle. The fuel cell is also very suitable for refrigerated vehicles, which has a great advantage over pure electric vehicles. Another product is the 1,000 kilometer range fuel cell heavy-duty truck with liquid hydrogen. This truck is driven by in-wheel motor, and the hydrogen is stored in the liquid hydrogen tank using a high-powered fuel cell. And this vehicle is already available here in China. And then, now we are preparing for a large-scale hydrogen demonstration at the Beijing Winter Olympics. And during the Winter Olympics, there will be nearly 2,000 fuel cell vehicles operating in Zhangjiakou, Beijing, and over 20 hydrogen refilling stations in operation. And there are already 350 fuel cell buses in Zhangjiakou now. Looking ahead, we have also developed a technology roadmap for fuel cells in commercial vehicles, and then the cost of fuel cell systems in China will drop by more than 80% in the next 10 years. This is very much similar to the process of cost reduction of lithium-ion batteries in China over the past decade. And this is the 2020 version of the China Hydrogen and Fuel Cell Technology Roadmap developed by Chinese Society of Automotive Engineering. We expected that in 2025, China will promote 50,000 to 100,000 fuel cell vehicles, mainly commercial vehicles, and between 2030 and 2035, approximately 800,000 to 1 million fuel cell vehicles are be rolling out, and also mainly fuel cell heavy-duty long-distance commercial vehicles. So this is our overall plan, and in all aspects, including the fuel cell hydrogen refilling stations, which will exceed 5,000 by 2035. And of course, we are still facing some technical challenges in the fuel cell vehicles, such as density of onboard hydrogen storage and the cost of hydrogen storage. In terms of the fuel cell onboard hydrogen storage, our mainstream technology is still gas state high pressure hydrogen storage. However, the density of hydrogen storage is not very satisfactory, and cost is still very high. I'm talking about the current cost. And we expect the costs are going to be dropping continuously. However, in the middle of the total cost of our fuel cell vehicles, the cost of onboard hydrogen storage is still high, relatively speaking, mainly because of the cost of onboard hydrogen cylinder and carbon fiber. This is the second aspect. And then the third aspect is the introduction of some of the technical economics of the whole hydrogen energy industry chain. And now the current global situation of hydrogen energy is that clean energy hydrogen production and the use of hydrogen for energy purposes is still in its infancy. For example, clean energy hydrogen production still accounts for less than 1% of total hydrogen production. Therefore, we must vigorously develop green hydrogen, i.e. hydrogen production based on renewable energy sources. And the core technology in hydrogen production is the electrolysis of water, which is the internal process of hydrogen fuel cells. We believe that the future demand of hydrogen energy, especially green hydrogen, will be huge. Therefore, electrolysis water hydrogen production will be the next most important development area after hydrogen fuel cell power generation. And we believe that the electrolytic water to hydrogen system industry will be a high-tech industry many times larger than the fuel cell industry. So for near, medium, and long-term applications, China has fully developed and industrialized 3 types of electrolytic water to hydrogen technologies, including alkaline electrolysis, proton exchange membrane electrolysis, and solid oxide electrolysis. In the middle of this, we could see that the efficiency of the 3 electrolytic hydrogen production technologies is gradually increasing, but at present, alkaline electrolysis is still the mainstay in terms of the investment cost and typical commercialization scale. China has an industrial chain advantage in the field of alkaline electrolysis for hydrogen production and can provide a low-cost hydrogen production system for the world. Looking into the future, according to the International Renewable Energy Associations, we are predicting that the cost of hydrogen production will continue to fall, a trend that is also appropriate in China. We expect low-cost photovoltaic and wind energy sources, and soon hydrogen production costs will be comparable to traditional chemical-based hydrogen production costs by 2025 this year. So even after 2035, they will be lower than traditional chemical-based hydrogen production costs. So the outlook is very promising. And then in terms of hydrogen energy storage and transportation, in China, we have compared various different long-distance storage and transportation technologies over thousands of kilometers, including liquid hydrogen, gas hydrogen trailers, and so on. And we believe that the use of China extra high voltage transmission lines for long-distance transmission and local hydrogen production is one of the advantageous channels for long-distance storage and transportation of green hydrogen. This is analysis of cost of transporting hydrogen over thousands of kilometers using China's ultra-high voltage transmission lines and local hydrogen production, which shows that this is quite competitive. And then, in addition, in terms of hydrogen storage and transportation, liquid ammonia has a high density of hydrogen storage and convenient transportation, and China has a very strong industrial base and a very convenient way of using it, which we think is also an important way of hydrogen energy storage and transportation. As you can see, we can store hydrogen at a density of 17.8 kilogram by weight of liquid ammonia for 100 kilogram. In comparison, a 70 megapower high pressure hydrogen cylinder can store only 5 kilo. And for the volumetric hydrogen storage density, liquid hydrogen can only store 50 kilogram of hydrogen per cubic meter, whereas liquid ammonia can store 120 kg of hydrogen. So at the same time, the process of ammonia production, which currently has industrial catalysis to synthesize ammonia, which is very popular and mature in China, And then in the future, we have electrochemical, electrocatalytic synthesis. So there is a lot of potential in terms of technological process. And ammonia decomposition could also be used directly for power generation and also directly for fuel cells and so on. So it is a very good vehicle for hydrogen storage and transport and utilization. So in terms of the whole chain, there is still huge scope of reducing costs and increasing efficiency in the hydrogen supply chain for fuel cell vehicles. So we need to optimize the technology across the board. For example, the energy consumption is still high for transportation and refilling. So we need a new breakthrough in science and technology across the whole chain. Last but not least, I would like to make a conclusion. Hydrogen is the strategy and also strategic energy carrier to achieve global carbon neutrality, but the green hydrogen technology cannot yet fully meet the market demand economically. Facing the opportunities and challenges of hydrogen energy, international cooperation on hydrogen energy is urgently needed. The establishment of Beijing International Hydrogen Energy Center will build a platform for cooperation. Let us work together for the sustainable development of mankind. Thank you all for your attention.